Hello, everyone. Welcome to the binary episode of the podcast for this week. For those who didn't catch our usual Monday time slot, we've split the podcast into two, doing binaries and higher level web stuff on our usual times on Monday at 3 p.m. Eastern. Um, and now on Tuesdays at 7 p.m. Eastern, like today, we're covering binary and lower level research type topics. We just wanted to split it up so that people who wanted more of the lower level and didn't necessarily care for the web stuff, or vice versa, could choose which one they tune into. It also allows us to cover the topics a little bit more in detail because we don't have to worry about running for like 2 hours or whatever like we were before. So yeah, bit of an exciting day. New podcast time slot. And while it's not exactly podcast related, I don't know if you saw Z, but The Matrix 4 released teasers today. Probably a series that's popular with a lot of the people in our community, or is at least known to them.
I did
Uh,
not know that. I heard that they were working on The Matrix, another sequel to it. I haven't really kept up with it at all.
yeah, there were a lot of people thinking that it was going to drop sometime next year, but it's actually going to be dropping December of this year. They dropped a neat little teaser site where you can pick like the red or blue pill, and it'll show you a customized teaser trailer for that. Just thought I'd shout that out because it is kind of like a very cultured movie, I guess, when we're talking about infosec.
We
So
need a sequel to the original, like, what was it, 93 or 95 Hackers movie, or just a remake.
oh yes, remakes always go over really well.
Yes,
I'm
always.
sure. I'm sure that'll be a good idea. Anyway, before we get into topics, a few other things to mention. First up, we'll cover the solution for yesterday's Spot the Vuln challenge from Z. Z, you can go ahead and spoil the challenge now.
Yeah, so with that challenge, and just so people are aware, we're going to be showing kind of these spot the vuln challenges at the start of every episode now also. So at the start of yesterday's episode, we indicated that the solution would be on today's episode. Obviously, today's episode, we get to talk about it. A vulnerability here has to do, or I kind of hinted at it with the name. You can see in the code here, you've got get data, and I apologize for our listeners who can't actually see the code that I've got up on screen. But effectively, you've got get data, which in theory is taking in a socket. Actually, I've got as in sock, which feels wrong. Oh, socket FD. Okay. I'm forgetting what all the code is. Uh, the gist of what the function is supposed to do is it's supposed to parse it for data. So it reads the length out of a header and then just parses that much data. Leaving out some of the details, it looks at the length and parses that out, reads, network to host, changes the byte size there, byte order. Checks the length, make sure it's not more than 1024 plus the size of the header. So effectively, that's going to be the buffer size. Um, Making sure you're not going to overwrite the buffer, and then it reads from the buffer into, or from the socket into that buffer. Problem being, you've got the length check for, or sorry, when it's reading from the buffer, it also subtracts the header size. And that's kind of the key vulnerability here. Because when you do that subtraction, it checks if the length is long enough, or it is not too long, I should say. It doesn't check if the length is long enough. By that, I mean when it does that subtraction towards the end there, line 19, it does length minus size of struct header. It's, subtracting the length from what it's reading, or subtracting the header length from what it's reading, because it's already read the header. When it does that,
Basically,
if the length is too small, that'll go from 0 and then to some large number as a negative. Well, negative number being like 0x etc. Uh,
yeah,
it'll read way too much data.
yeah. Basically, if the length is smaller than the header size, it'll underflow, and it's the main problem there.
Yeah, that's
Um,
more succinctly put.
yeah. Somebody in our Discord also found a kind of unintended bug that could be there, depending on if you want to be favorable towards Z or not. Because if you assume that the read sock function doesn't implicitly zero the buffer before reading user data in, there's also a potential uninitialized use there because um, as it is currently there, the buffer on the stack and get data is not being zeroed or anything. It's just just an uninitialized stack buffer. So, if you want to hate on Z a little bit, you can say that there's also a second bug there. If you want to be charitable, you can, in your head canon say that read sock just implicitly zeros it. But
It's
I wanted to
totally
call that
fair
out because
to
it is a good
yeah,
thing
it's
to
a
call
good
out.
find. It's a good call. Good shout on that. I mean, when I'm writing some of these, I mostly think about the vuln that I want to get across, and not necessarily every possible vuln. So it's always interesting to see what other people find. I mean, I'm a fan of unintended solutions, like with some of the challenges I've made, like for CTFs. As much as I try and prevent like really stupid unintended solutions, I do enjoy seeing them also, because it's just people have other ways of looking at these things. So I mean, it's just nice to see, I guess. Out
Yeah,
of chat, JHK Ross, that's what's the first if condition for. The first if condition is reading, uh, that's line 12. That is reading the header.
that's reading the header. Yeah. Um, and then Amy also just pointed out in chat a good CTF tip: people forget about reading less than expected data all the time. Um, yeah, I mean it's easy to think about overrunning the buffer with too large of a size, but it's easier to miss this like not long enough. Just not considering that underflow possibility. So yeah, for sure. Um, Another thing I wanted to get out of the way before we get into topics, now that we covered Spot the Vuln, just a warning up front. If I abruptly drop out of the podcast, it's because I lost power. There is a pretty big storm going on where I am. We've gotten a few tornado warnings and nothing huge. We've also got some hail. So yeah, um, it's kind of funny because unfortunately, while I'm on a backup power supply and my router is as well, my ISP decided they didn't want to pay for that. So even if I keep my power through a like backup power, the ISP doesn't have that, so I will lose internet. So yeah, just keep that in mind. Hopefully that doesn't happen, but we'll see how it goes. Um, but yeah, now that we've got all that out of the way, we'll jump into some topics. Let's start off with a fairly easy set of attacks against Honda and Acura vehicles. This was a named set of attacks that dropped on GitHub. They called it unoriginal rice patty. I'm not sure if they really go into the detail on the name. I didn't. Oh yeah, they
Yeah,
do a little bit.
it's like the very first paragraph they talk about how they got the name there, just being from the fact that Honda in Japanese translates to original rice patty.
Ah, fair enough. Yeah, I think I saw that section and I just kind of skipped past it to get to the issues. Um, but yeah, as the title suggests, it is a replay based attack. There is no protection against replay attacks. You can literally just capture signals sent from key fobs for like unlocking doors, locking doors, and then replay them again later. On top of that, you can also demodulate the commands being sent, and you could take something like a lock command, flip certain bits that they mention in the README, and then use that to unlock the car. So it's even worse than just a replay issue because you can actually take not like a lock command and then change it to an unlock command. The keys aren't very different. So yeah, just kind of
Yeah,
meme issues on Honda and Acura.
it surprised me, and actually for the same reason Dilbert Mark just mentioned, Chad, amazing this vault exists in 2021. That was exactly my thought, and kind of why I wanted to call this out. And as a vulnerability, it's not that interesting. We've covered definitely more technically involved things, but like rolling codes have been around for a long time. Like I'm pretty sure my garage door opener is more secure than this. So the fact that like Honda is still doing that, like I'm genuinely surprised that a vehicle manufacturer isn't at least using like a rolling code type of system for this. Because I mean, that's basically what you would expect. I believe that's kind of what the majority have done. There might be some who go a little bit more secure than that, but I don't know. It is genuinely surprising that this is the type of volume that we're seeing now, and across potentially a lot of vehicles. They only have a handful of confirmed ones here, but it's a good mix of vehicles, which indicates that is likely throughout like an entire or throughout a lot of their vehicles.
I mean, generally, something like the key fob is not something that you're going to change all the time. You're probably going to use that across most of your models, unless you're doing something like you're adding a new feature or something to it, maybe. Um, yeah, it just seems like something that would be very easy to get right. Um, said it's the rolling code's kind of been around for a while. We've seen some security assessments that have been done around uh, fob-based blocks. Like I think we covered one where you can install them in your home, and those like they had some issues. I forget exactly what the issues were. They were mostly on the crypto, like they used bad IPs or something. But even they weren't susceptible to such easy replay attacks. Um, what makes it even worse is the fact that um, the one car that they listed, the 2017 Honda HRV, that received a CVE for this, Honda didn't even fix it. Um, not even in that just that one car. And they also won't respond to the researcher. So it seems like Honda has no intent of fixing this problem. It seems like they're okay with just leaving the ability to do replay attacks against their vehicles.
It's a
Um,
feature, not a bug.
yeah, according to according to Honda, yeah.
I mean,
So
it's also one of those. It is just, it's a well-known issue that should be fixed already. That really shouldn't have even been put out into production. I mean, I guess to be fair, this covers vehicles from 2009 up to 2018. They didn't test any 2021 vehicles. Um, at least I don't believe they did. Oh no, a 2020 Honda Civic. Never mind. I just had that blocked on my screen. So they did test one 2020. So I mean, maybe not enough time to patch it since then. I mean, I'd maybe want to see a 2021 vehicle, but that's being generous.
yeah,
The other thing is like this does include starting the vehicle, not just unlocking the doors. At least on newer ones, obviously, not all vehicles have that remote start, but it includes that, which to me is a pretty big deal. Although, in
so
fairness, you usually have a steering lock that would prevent somebody actually driving off without a key in the ignition,
yeah,
in
that was
theory.
what I was about to point out. You're not going to be able to take it and drive away generally, just off of a remote start. That said, the remote start does grant you access to features of the car, like the infotainment system and whatnot, which
That's what
somebody
you'd
could
want to do.
potentially mess
Break
with.
in and listen to music.
Well, I was thinking more like if you wanted to mess with settings in the car or something. I don't know why you would do that. Generally, I think if you were trying to pull off this kind of attack, it's because you were going to steal the car. But there is a potential for other attacks too,
I
as
mean,
unlikely as
yeah,
those may be.
unlocking the vehicle is still an issue. Oh,
For sure.
just stealing in general, especially if it is fairly trivial to do. Target attacks, yeah, but yeah, fairly easy vulnerability.
Now, the author is being a bit charitable to Honda here, saying that this would be very difficult to patch retroactively, saying that Honda could begin to implement security measures in future vehicles, but it doesn't seem like they will go back and fix the issue. That said, that doesn't really excuse them not even responding to the issue at all. Like, if they would respond and say, okay, we're not going to fix this in our existing models, but we will fix this going forward, that would be like very different. That would be very reasonable. But the fact that they don't even really want to acknowledge it, and like that CVE was filed. When was that? Yeah, that was a 2019 CVE, and there is a 2020 model here. So if they were going to fix it for future models, they hadn't done it by that point. So yeah, I mean, maybe for future vehicles they'll implement a more secure process, but at least as it stands, it's
Yeah, that's
kind of
kind
a
of
joke.
why I would have liked to have seen, 2021 vehicle to say it's still there definitely after having the report in 2019. I mean, I could understand not having 2020 fixed. Hopefully by 2021, new model year, would have had more of a chance to fix it. So I'm still a little bit hopeful. I was also just looking up to see if Honda has any bug bounty program, and I don't really see anything. I was able to find GM with one though.
That's interesting because I haven't really heard of any car manufacturers having like a bounty program outside of like Tesla.
GM actually
Um,
has one right on HackerOne too.
Interesting. Okay. Um,
Um, all of
they
their
they do
hack.
need to become more popular for cars. I think more car companies should be adopting security programs, but
In
it seems
fairness,
it's not that widespread at least yet.
In fairness, just looking at the GM one, it's actually reasonably active too. I mean, it's not super active. Last disclosed thing, well, not disclosed, but last things we see information about were 13 days, but they have a fair number on there, so at least it's getting used. So good on them. Like I said, I can't find anything for Honda though.
Yeah. All right, but yeah, mostly I guess a PSA to people who have those Honda vehicles to be aware of it. I mean, I guess there's not really much you can do, but it's just kind of sucks for people who own those models, I guess, that they can be so easily broken into if the determined attacker wanted to. Anyway, yeah, like you said, not a very interesting issue, so we'll move into something that is a bit more interesting. Up next, we have a ZDI post covering a heap overflow in the InnoDB memcached plugin. I'm not sure if it's memcached or memcached. I don't know. I'm going to go with memcached because it sounds more mystical. But yeah, that's a plugin for MySQL. Specifically, the get command implementation has an issue. The bug is that classic problem of using an assert for doing bounds checking, which in non-debug builds does absolutely nothing. So the debug build is secure, but production builds are not. And the main problem there is when copying the table name into the row buff buffer for doing the get command, the assert will check if the amount of the row buff already used or the cursor plus the table name would exceed the buffer size. But again, because that assert isn't in release builds, that check effectively isn't there in production, and that table name can overflow. Um, Now, it is worth mentioning to trigger the bug, MySQL must be built with the with InnoDB memcached on macro set, and that is not enabled by default. So that does really limit the impact of this, where you would have to hit a target that specifically built MySQL with that InnoDB plugin enabled. Also, you would need the ability to get control over get commands being processed by InnoDB. So that is a fairly significant foothold that you would need to have as an attacker to take advantage of the bug. But
Yeah,
yeah, I
that
mean, if
was
you can take advantage of it, this is a fairly straightforward overflow.
yeah, that's kind of my thought here is straightforward bug, but an attacker actually having that well, I mean, there's a chance they might be able to provide like the at in there. It's usually like memcache is going to be called more by the developer, less user control over like what keys are actually being called and all of that, or a lot more restricted control. I could imagine some scenario where this happens, but yeah, it does feel fairly unlikely. But I mean, a lot of bugs are that way where it's like you need just the right scenario to actually abuse them, and then you've got something. And
What I
yeah,
would
like
say here, though,
oh, go ahead.
is just that even if you could take advantage of this issue as an attacker, I don't know what it would gain you necessarily. Like, I don't think you would be able to use it as like a privesk. If you can already use commands and like run InnoDB commands, um, then does taking over the process really gain you anything? Is the
It
process going
gains
to be
you.
running at a higher privilege level? I'm not sure.
Well, I mean, a lot of this it's through the database, so this is going to be a separate server usually. Or it
Oh,
could
I
you could
see.
be running memcache on the same server, but it's still going to be at least the attack scenario I'd be thinking of is a user is able to control what's being looked up. So like you're using a website and you have some influence over the keys being looked up. So this would be kind of remote code execution in that sort of case.
Yeah,
And yeah, if memcache, well, this is on the MySQL side, I guess. So not necessarily where memcache is running, but where MySQL is running, which may or may not be the same server. Usually for
yeah.
latency, at least my experience with memcache, somewhat limited in production, but has been that memcache will be on the same server. Because I mean, you're doing it in memory, so you kind of want
Yeah,
to avoid the
so
latency.
I guess that's a fair call out where somebody can control it from the site side. That could be used for RCE, but um, yeah, I don't know how likely that scenario would be.
Yeah, the main
I don't know
takeaway
enough to
though
comment.
is just the fact that it's the assert that's doing the security. I think. I mean, that's. I feel like we've seen this before. I can't recall
We have.
when, but we've definitely seen this sort of thing in the past. I mean, it's common enough that it's really just something to kind of keep an eye on. Like when you see asserts being used, but nothing that actually I guess, follows it up. No if statements afterwards.
So it's kind of funny. I just did a quick grep in show notes for past episodes just to see where we would have covered this before. And it was in episode 41, and it was in the Windows kernel, of all things. There was the title of the topic was How a Deceptive Assert Caused a Critical Windows Kernel Vulnerability. And yeah, it basically that one was a little bit different. It boiled down to the fact there was a function where like Microsoft telemetry assert triggered no args km was mislabeled. It said it was an assert when it wasn't. So that assert, well, that function didn't actually do anything because again, it was kind of like a developer build type thing. It actually just sent telemetry back. It didn't terminate execution. So kind of similar, but yeah, I mean, I just don't really understand why assert seems to be common to use for error checking in these codes or in these products. Like, I mean, yeah, I can see why you would want to have developer assertions in development, but I don't understand using it as a bounds check like this. Like, what makes you write this and think, I'm not going to need to check this in production? This is only going to be an issue in development. Like, it's just weird.
Or just the
Um,
fact they'd probably want to come across the bugs that are obviously causing that in in development rather than in production. Not so much saying that they only need to protect against it. Like they probably aren't even thinking about writing that as a protection, but as a warning to the dev that they're doing something wrong.
Yeah, I guess that's fair. It just seems weird to me that you would take that step of knowing, like, hey, I want to know if there's a problem here, but I don't want to actually check if the user can cause it. It's just, I don't know. It seems weird to me. But anyway, um, like you said, it makes it misleading when you're reading the code because if you're just doing a quick scan and you see, okay, there is an assert here, um, I'm assuming that it wouldn't just be in debugs builds because that would be stupid. So yeah, there's no bug here, and then just continue,
I
right?
mean, the assert thing is pretty common to not production. So like when I see an assert, I don't necessarily think it's going to be in production. That's not really my go-to thought.
I feel like somebody who's just doing a quick audit of the code though could easily just skip that and they might not even look at the assert. They might just see that hey, there is a length check here. So just move on. Like if you're just doing a really quick assessment. Um, but yeah, I mean, like you said, not the first time we've seen this issue and won't be the last most likely. So um, but yeah, it does offer a fairly powerful primitive. They don't go into exploitation details, which is somewhat common in the ZDI posts. Sometimes they do, sometimes they don't. It's kind of hit or miss on that.
Yeah, I guess
Um,
speaking about exploitation, actually, so you likely have some control over where it's going to be written in a sense. Like you can push it out a potentially good distance. You can be strategic, I guess is what I'm saying. You can push it out a certain distance, but you are limited in what it's actually writing out of bounds. Because it's going to be writing the table.
yeah, you're going to be
So
limited by the table name restrictions.
yeah, exploitation here would be a bit tricky. I mean, in the right scenario, like I said, you're only jumping by like that table name every time. So how far you write. Well, I guess yeah, you can't. I was thinking you could be a bit strategic by jumping over some things, but you can't because it's going to be writing other data if it's not writing that in particular.
Yeah, you would have to do some pretty crazy feng shui to abuse this. That said, in a product like MySQL, where strings and keys and lookups are used quite a lot, I could see like a potential way you could take advantage of this.
Yeah, no, there's definitely
Um,
the chance for it. It's just you don't control what's being written too well.
Yeah, it's fun to speculate on, but it's hard to say. You'd have to really play with the exploit and just try yourself to see if it could be taken advantage of. But yeah,
Yeah.
like I said, ZDI doesn't really go into that. They do go into the patch though. The patch is fairly trivial as you'd imagine. They just removed the assert and they added code to actually check um, the current robuff used cursor, and if that plus the length of the table name would exceed the size of the buffer, they then um, they limit the record size to 16 megabytes, and then they reset the current cursor position so that it doesn't end up writing out of bounds. So, yeah, fairly straightforward patch. It's basically just what they should have been doing in the first place. So, um, yeah, but like I said, fortunately, not many details on the exploitation side of things. Although in the conclusion, they do say it would not surprise me to see a reliable exploit in the near future. So there you go. I guess that's kind of a hint stating that they think that it's probably exploitable. So, but yeah, that's all for that topic. We'll move on to Checkpoint, who did a post about an out of bounds read write they found in WhatsApp in the image filter functionality. They didn't see any evidence that this was being abused in the wild, and the attack process does require the victim to do quite a few steps for them to be impacted by it.
Yeah, this
Um,
would be hard to, I think, actually hit in the wild.
for sure.
The simple process here is you have to get somebody to perform a filter on a maliciously crafted image. So effectively, an attacker sends you an image and then you apply a filter on it and try and send it back or send it to somebody else. Uh, just the fact that you need to be using the malicious, basically, it's almost like a self attack, unless you can come with a way of getting the user to perform it. Um,
There'd be some social engineering involved if you were
yeah,
actually trying to hit a target with it.
I would call this kind of just a self attack, although there is a conceivable way to do it. Because I
Yeah.
mean, you don't. I don't use Snapchat, so I don't know what like the social aspect of that's like. If people show off filters, but I could imagine the scenario like, hey, check out what this filter does with this image. And then just sending them over the malicious image and that. Like I could imagine that sort of dynamic, but this isn't the sort of like stealthy attack where you just send them a message and you compromise them.
Yeah. So, like Z mentioned, you have to open a maliciously crafted image file, so that is the basis for the attack. So let's talk about the bug there. So they discovered the issue when fuzzing with AFL. Not too surprising, given that we're talking about images and file format type bugs. Um, they first go into some background about how filters work, mainly the fact that they apply transformations on the underlying pixel data of the image and then save it as a new destination image, which means that it's a very nice target to look at for fuzzing, right? You're getting data parsed out of the original image, being translated, whatever, and writing a new image. Um, Ultimately, they discovered a crash when switching between filters on fuzzed GIF files. After pulling the crash and doing some root causing and reversing, they pinned the bug to the apply filter into buffer function in the WhatsApp library. Um, and what ended up happening was there was an out of bounds access that could happen when the function iterates to the source image pixels, then applies transformation on them, and then copies them out to a destination buffer. The problem there is they assume that the source and destination image both have the same dimensions as well as the same pixel format, being RGBA as 4 bytes, so 1 byte per color channel. But if that assumption is broken and the source image uses something like 1 byte per pixel, then out of bounds accesses can occur because they never actually check that the source and destination images are both of the same format. So if you have a malicious source image with only 1 byte per pixel instead of four, the function will try to read and copy 4 times more data from the source image, which is where that out of bounds access happens. So because of that, um, like uninitialized data, or I guess out of bounds data, ends up getting copied into the destination image, which, if the user sends back to the attacker, can contain sensitive information. Um, the patch involved adding 2 checks on the source and filter images. First, it checked to ensure that the image format is the same as the filter and therefore the destination image. And two, it validates the image size using the stride, which is like the pixel depth, I believe, to ensure the image has exactly 4 bytes per pixel. So, yeah, kind of an interesting bug. Not the first time we've seen a bug like this. We've covered a bug in the past I think it was WhatsApp as well, actually, in GIF parsing, where they made some assumptions on the image data that they never verified, and it led to a very similar issue.
Might have been
So
WhatsApp, might have been the Telegram sticker issue.
yeah, it might have been. It seems like it's something that's very easy to
Image
get wrong.
processing, yeah, is a lot of things have gotten it wrong. I mean, not just WhatsApp, although we've seen some things out of WhatsApp in particular, because it is a nice target for those sorts of vulnerabilities. Somewhat
Yeah,
difficult to exploit anything when it comes to the images, just because of the fact that it's effectively a one shot. Trying to beat ASLR, but you've only got the one shot, the pre image to actually do it. Does make it a little bit trickier to exploit. Not impossible. We have seen some exploits that have managed it or have managed to leak the information before generating an image, perhaps, or something like that. So, like, it's not impossible, but it does add some challenge.
the other thing is that this is just I mean, I say just here, but it is like a leak. It's not letting you corrupt memory, so you're not going to be able to use this to get like code
Fair
execution, for
point. Yeah.
example. So that's kind of the main limiting factor, is that you do have to get them to send the image back. If it was just that you sent an image and you got them to apply a filter on it, that would be a lot simpler, I think, of an exploit process to attack a victim. But needing to send the image back is kind of suspicious, I guess. I think it would be hard to get a target to do that. Now, in credit to WhatsApp, their response indicates that they took the bug seriously, even though, like we're saying, this would have been a fairly complex attack scenario. Um, Given that it was a complex attack scenario, it's probably pretty likely that this wasn't actually used in the wild, and like they said, they don't have evidence for that. So that's kind of a good sign, I guess.
Although I
But
feel
yeah,
like getting evidence might be a bit tricky. I saw that statement, but it feels like, what are they going to do? I mean, I guess it is Facebook who owns WhatsApp, I believe. So maybe they do store every image that's ever been sent. They just look for any like 1 byte ones. I don't know. I
I
feel
mean,
like
yeah,
it
like you
could be
said,
difficult. Maybe
if
they
they do
save.
store the images,
Yeah, maybe they
yeah,
save a
you would
lot.
have to have the original images to be able to check. Um, but yeah, still a cool issue though, even though the attack isn't super easy to take advantage of. I think just image data is just one of those things where there's always going to be bugs. So Bhyve is back in the podcast this week in the form of 6 different bugs that can lead to escaping Bhyve's virtualization in various drivers on the host.
Six
Bhyve, for
different
those that don't
bugs,
know,
or the same bug 6 times.
yeah, basically the same bug 6 times. Um, but yeah, Bhyve, for those that don't know, it's BSD's like virtualization solution. So it's kind of like their version of their Hyper-V, I guess is a good way of putting it if you're not familiar with it. Um, like Z said, this is technically 6 bugs, but it's basically the same bug, all in just different places. Um, the first issue is an uninitialized use due to bad error handling in PCI VTRND notify, which is used for exposing hardware RNG. Um, Basically, when they go to copy the random values into memory through the VirtIO queues, they use this function called VQ-GetChain to fill the IOVEC structure in order to know where to write into the guest's memory range. Um, the problem is, if the guest never actually sets up any queues, then VQ-GetChain will fail, and it'll return -1 to indicate that it failed. But there's a lot of areas in the code that don't actually check VQ-GetChain's return value, or they check it incorrectly. So PCI VTRND notify is one of those places. It doesn't check the return value. So those IOVEC structures get filled with uninitialized memory. Um, it also, yeah, I mean, the other thing is it's very easy to make this function fail. So if unchecked return values is a fairly common issue, right? Um, it does generally get a bit harder to trigger in the fact that, like, how do you make that function fail, right? Usually it's like you have to exhaust memory or something like that, but this one's dead simple. You just literally need to make it so you don't create any bird IO queues for it to read into. The second bug is the exact same issue in PCI VT9P notify. Don't check the error handling using an uninitialized IOVEC array. PCIe VTCon sock RX has the same problem. Uh, the fourth bug is a little bit more interesting. It's in PCI VTCon notify TX. It tries to do error handling on VQ get chain, but it does it incorrectly because it stores a return value as a uint16. And since the VQ get chain function returns a signed integer, that -1 ends up getting stored as a positive uint16 integer. So they do error handling that doesn't do anything because it's broken. Um, but yeah, after that, the other bugs are back to just no error checking in VT-SCSI control queue notify and VT-SCSI request queue notify. So yeah, basically all these bugs are the same problem, just not checking the return value on VQ get chain. This is one of those reports where they probably found one of these issues and then they just did variant analysis to see where else this issue could exist. And it turns out it exists in a lot of places. So they ended up getting 6 bugs for the price of one, basically. And this is where something like CodeQL can be very useful. I actually wonder if they used CodeQL here because this is coming at a GitHub Security Lab.
Yeah, I could
I don't
imagine
think they
that they
mention it,
did, but it's not
but
mentioned.
yeah, I'd speculate they probably did use um,
I mean, it's
CodeQL or something
definitely
similar to it.
definitely an easy enough query to do. I mean, they actually in the standard library, there's a query that maybe wouldn't catch this one, but it catches cases where most calls to a function capture the return value, and then captures all the cases that don't use the return value. So when they're like the odd one out. Balika in chat asks, don't they give warnings for unchecked return values? I'm not too sure what the process when it comes to FreeBSD on like their normal compilation channel. On a Spectre, I guess you might be more familiar on building FreeBSD with the PS4 work, though I can't imagine you actually need to build it for that.
I built the BSD kernel. Um, I've never really looked at Bhyve. I don't think BSD's development process is that thorough, where they're running like linting and SAS tools on it. At least when I was with the little bit of building that I was doing, I didn't really see any indication of that. And BSD is kind of a meme when it comes to security bugs, so I very much doubt that they have any tools that are checking for that. Because I don't think the compiler warns you about unchecked return values, unless there's a flag for that. And I don't think I've ever seen a warning directly from the compiler about that.
Yeah,
Um,
WAL would. Like it is a supported warning. I just don't know if they by default would be building with it or not.
yeah, especially with something like Beehive, I could see them not using
Like
like all warnings.
I guess that's kind of my question is more like does their build with WAL actually have a lot of warnings that they otherwise, in which case it would be easy for this to kind of fall in on that. And given the fact that it exists, I guess I'm going to just have to say probably not.
Yeah. Um, so yeah, I mean these unchecked return values they're fairly common in complex code bases. Error handling is difficult. That is why the fault injection frameworks and stuff exist, is specifically to test for issues like this. So um, yeah, not something you would have caught if you unless you were looking for it, but it is a pretty substantial bug. And because this is in Beehive and it can be triggered from a guest, the impact is pretty high here. This can allow for a VM escape. Um, Probably all of them could be used for a VM escape because they're all the same thing, basically. When you're talking about what this issue caused, which is using IO vects that are using uninitialized data, that sounds like it'd be pretty damn easy to exploit. You would just have to spray the heap with pointers that you would want in the host memory for it to write to, um, and then just have the IO vects get used. You have an arbitrary write into host memory. So yeah, it doesn't seem like it would be a super hard exploit to pull off. Though,
Of course, it's
actually,
easy to
no,
say that until we're actually trying it out. I'm
that's
not so
true. I
sure
am
about how.
armchair exploiting here.
Yeah.
I was about to say it might be difficult to get like a leak, but it's an IO vec. Those can be used for reads and writes. So as long as you have anywhere that uses it as a read, you can pretty easily leak host memory too, I would imagine. So yeah, this could be fairly easy to take advantage of. Again, though, just like ZDI, they don't go into exploitation details. They just kind of cover the bugs. Um, Although they do have POC resources, although that was for building an EFI disk. I didn't really understand what the POC snippet at the end was really trying to demonstrate. Um, but I don't know, maybe somebody else out there, like one of our listeners, would know more about how useful that is. But yeah, I don't know. To me, that I didn't really see what the point of that POC snippet was, but because they echo like main.c, but I don't think they actually have the main.c source code there. So it just seems like it might be an incomplete POC.
Well,
Um,
so they provide I'm not sure if it's what's supposed to be the main.c, but they do provide code for a proof of concept also. Not just the image build. It's just done earlier.
oh, I see. Yeah, yeah, okay. So that's probably what they're doing is you just pull that into a main.c and then you run the image. That makes more sense. Okay, so it's just fragmented a little bit. So yeah, I guess anybody out there is looking for something fun to do. You could give these bugs a try. See if you could exploit this against Bhyve. That'd be that'd be pretty fun because virtualization is always an interesting target. Yeah, with that said, we'll move on to a Synactive post, which covered a bug they found in the web server of Western Digital Pro PR4100s, which is a NAS. This was also a target in Pondo and Tokyo 2020. So that's part of the reason they were researching into it. When they were looking at it, they audited the web server and looked at the CGI bin they use for implementing it. Out of all places, they found a bug in the login functionality, which takes a username and base64 encoded password, which later gets compared against the SC shadow file. Um, they were just taking a look at the code and looked at WD login's function, and they found kind of a code smell. They found that it would take a 256 byte base64 string for the password, which is quite large. That would allow a 192 byte raw password length. And that was weird because the buffer for the raw password was only 64 bytes in length on the stack. In fact, they claim that this might not be a bug, but I would say it is a bug because what ends up happening is when it goes to decode the base64 encoded password, it does so across two different buffers on the stack. It overflows the PWD buffer and runs into the B64 PWD buffer, which is the input buffer. Um, so because it kind of bleeds across two different buffers, it is an overflow. It's just not immediately useful. Um,
Yeah,
so
like
I kind of disagree with it not being a bug.
you don't overflow into anything useful. It's a bug. I think more a question, is it a vulnerability? Obviously they're able to abuse it to kind of have a useful situation. And I mean, I would still argue it is, mostly because the only thing that's saving them here is the stack order. And
Yep.
that is purely compiler dependent. You build it with something else one day or some different flags, you can end up with a different stack order, and suddenly it is exploitable. So I'd still call it a vulnerability, but I can understand where an argument can come from, especially if you hold the belief that your declaration order is your stack order. If you don't give the compiler that ability to change it, um, which I don't think you can actually turn off on like GCC or Clang or anything. Um, then I can kind of understand making that claim. But it's not something promised within the C spec. It's not really an option. So yeah, I'd still call it a vulnerability. It's kind of a fun or potentially fun issue. In this case, not really. They just use this bug. But the fact that you end up writing into the buffer that's also being read feels like you could have like a CTF style challenge out of that, depending on how the reads are happening.
Yeah. The other thing I wanted to mention is even if you ignore the compiler argument, where the compiler could change the order of the stack arguments on you, all it takes is a code change. If somebody wants to add a feature or add a parameter into the argument and then they add a stack variable, most people aren't going to be paying that much attention to the declaration order because it shouldn't matter. So the fact that the declaration order could be so important for taking advantage of a bug, I agree. It should be point of vulnerability. Um, but yeah, immediately this wasn't useful to them, but it was useful for taking advantage of a different issue, which was in a function that was called further down, which is the do auth with shadow function, which did the heavy lifting of actually checking the credentials. They found a stir copy call, which would take the decoded password and copy it into a 120 byte stack buffer. Because it's a stir copy and it's not being limited, it's not a stir end copy, there's a stack overflow there. Combined with the previous bug, you can create a really long string that goes beyond 120 bytes, which can lead to memory corruption and code execution by way of just overwriting the return pointer on the stack. There's no stack canaries in play or anything protecting the stack, so yeah, it's
which
pretty straightforward code execution.
for embedded, like no canaries, isn't too surprising. I will point out one smell here that I kind of noticed, and that is the seemingly arbitrary size choices. I would hope ideally they should be using like a constant value, and then the compiler just like whatever they're seeing here, I assume is decompiled and not necessarily the actual source that was written, because I don't believe the NAS is open source.
It is decompiled, yeah, because you can tell like they have the hex values for the function call arguments,
Yeah, so I would
which
hope that
would
they're
be very
using,
rare to see in source.
when it comes to the sizes, that they would be using like some constants to track those, so it's easy to keep track of, hey, this is this size. But then the fact that we see like in one area they're using 64 and 256 and these nice binary round numbers, and then in another area it's 80 and 120. Like these are just very arbitrary numbers, and it seems like it's very easy to make that sort of mistake on how big is something because of that fact. Like if you change it, you've got to change it everywhere. So that's
That's a
just
good
one
call
thing
out.
I noticed here. And Blika mentions in chat there that I remember when WD had 80 bugs published in bulk, and they refused to fix for months. It sounds like WD is just not a good brand for that, which is unfortunate
Yeah,
because
we'll
I
get to
like
that a
their
bit later
hard
in the
drives.
post. Yeah, yeah, WD is their reputation has been pretty shoddy when it comes to security, but also some other things. But yeah, they actually mentioned that directly in the blog post a little later, which we'll get to. Um, One thing that's cool with this blog post is, unlike some of the previous ones we've covered, they go in depth on how they took advantage of this. Because while getting code execution was pretty straightforward, they didn't have to deal with stack canaries or anything like that. Um, the Actually using that code execution to do something useful is pretty tricky. Um, because the libraries are mapped to 64-bit addresses and they are position independent. And you can't really leak as a stepping stone because the login manager they note is a transient process. So even if you manage to leak an address, if you can't exploit in the same process instance, then it's useless to you because the libraries will all have changed locations. They also can't put any null bytes before the first 120 bytes because obviously it's a stir copy. And they need 4 null bytes in the upper 32 bits of the RIP overwrite for their stack pivot. So they needed a one-shot exploit using gadgets found in the login manager binary because that was the only binary that was not position independent. They did find an import for the system function, but they didn't immediately control the RDI register for what to pass into system. So that was their main goal: was they wanted to call one of the places that called into system and get control over the RDI register. So they needed 2 gadgets. Um, After some searching, they did eventually find some gadgets that'll load an RSP address into RDI before calling system. Um, it was a little tricky though because they needed a range of bytes that they could control and stick like null bytes into or whatever that wouldn't interfere with the initial trigger, right? If you have any null bytes in those first 120 bytes, you're not going to be able to trigger the memory corruption. Um, they found a range after the return address overwrite that they could play with. And because it was in the base 64 decoded password, and they could completely control the encoded base 64 string, they could write arbitrary contents in there, including null bytes. So that range of memory, which I believe they mentioned, was like hex 110 to. Let me just check because I don't have the numbers in my notes. I forgot to get those. Uh, Yeah, it was hex 110 to hex 150. So that's kind of where they mentioned that. So being able to get control over that range was very useful to them. And they now had the ability to stack pivot twice. So they stack pivoted the first time to shift the stack pointer to be in that zone that they could write arbitrary bytes into. And then they pivoted again to call system where they now controlled um, like it would load that range of RSP into RDI and then it would call system. So they were able to pass arguments into the system function. Unfortunately for Synactive, this bug got patched 2 days before the end of registration for Prone to Own, which the Synactive authors hint that they think was intentional. This is where they note the bad faith of Western Digital being notorious among security researchers, going as far as to say that some researchers just don't even bother doing research on Western Digital products anymore because they just don't want to deal with them. So, it doesn't look too great on Western Digital. Um, but yeah, I mean, this was a nice blog post for showing that sometimes getting code execution can be easy, but it's not always easy to take advantage of it. Getting code execution isn't the last step. Um, the post exploitation matters too.
Yeah, that's
Um,
kind of why I like using the term control flow hijacking rather than code execution. I think that gives better nuance. You get the control flow hijack, but that doesn't mean you have code execution yet. Like you're able to jump around, you've got the route, but there's still more that needs to be done in order to actually get to your arbitrary code. So at least that's where I tend to choose that terminology. I mean, it I think gets across the point like there is still more to do after just your control flow hijack.
yeah. Near the end, they also conclude with some observations, mainly how similar Western Digital code and D-Link device code is, in the way that somebody else found a very similar issue in D-Link NAS. They suspect that this is because D-Link sold their firmware code to Western Digital, because D-Link apparently winded down their NAS product division. So they think they were just like, oh, okay, we don't need this firmware code anymore. Here, do you want to buy it? And they suspect that Western Digital probably did buy it, just because of how similar the firmware was. And that's where the your vulnerability is in another OEM in the title comes from. So yeah, that was another kind of interesting tidbit they threw in there. Um, and yeah, the Liga in chat is just kind of going off on Western Digital, saying that when Samsung SSD was out of stock and the only was available was WD, I decided to wait a few weeks. Yeah, I mean Western Digital when it comes to drives, I do own some Western Digital drives. That said, even in the drive space, they've done some shady things when, for example, they replaced the SSD controller on an established product line that they just never told anybody about. So the performance of the drive was a lot worse, because they cheaped out on components and they didn't want to disclose that. Yeah, I mean, Western Digital, it sucks because I have had a decent experience with their products, but it seems on the ethical side of things, um, they just don't really care about customers very much. So yeah, I don't know. Western Digital's a little bit weird as a brand. Um, but yeah,
Yeah, I
we've
will.
seen some Western Digital NAS issues before in the podcast, and I think we've seen the same kind of problem where they're just not really acknowledging the issue or acknowledging it like months and months later.
I mean,
But yeah,
there's a
go ahead,
lot
Sam.
of hardware like this, like not just NAS, but anything sort of running on any sort of cheap hardware, cheap security. So that's not too unexpected. I do want to touch on the bad faith aspect. Um, I mean, I get why researchers would feel like, they're patching it last minute right before own to own registration, or right before the event takes place, actually. I think this was patched a week before the event. Um,
2 days before registration deadline.
yeah, which is just for the event, I believe.
Yeah.
So I get why security researchers might feel that way, that like, the vendors are patching things right before, and no doubt some of them do have that in mind. At the same time, I don't necessarily think it's a malicious thing where it's like, oh, we're gonna keep this vuln in there to waste their time and then patch it. Maybe. I mean, it's possible. If anybody were going to do that, I think it would be maybe Western Digital. I could see that, but I've also seen those claims for like, Chrome and stuff. And like I doubt they have somebody who's just saying they're like, oh no, hold off on patching until right before or something. I've seen that claim made against a lot, and I feel like it's placing more importance on Ponto than it might actually get by the development team.
So this kind of brings up a discussion that I was that I've been thinking about for a little while, and it's that pwn to owns incentives are really weird for everybody involved. Um, because pwn to own, like the whole thing with it is if you're a researcher and you're submitting something to pwn to own, you don't want to report it right away. You want to hold it until you can use it at pwn to own and get paid out for it. Which does kind of encourage keeping bugs alive for longer, which seems a little bit weird when you are submitting them to the vendor. Um, and the other thing is, companies, for whatever reason, do seem to actually base their security, their performance when it comes to security based on pwn to own. Like, hey, did we? How many reports or how many bugs got submitted to pwn to own this year? Only one or none? Oh wow, we're doing pretty good then. Like that's what it seems like companies do. And I have heard some internal stuff around that too. That companies do look at pwn to own as a metric, and that could incentivize this idea of patching it right beforehand. If you let researchers think they have something and not dig deeper into your product because they already have something, and then you patch it last minute, then it looks better on you if you don't have any entries in pwn to own because you just burned the researchers right before the event. And it does happen a lot. There are a lot of cases we've heard in the past where issues have been patched like within a week of pwn to own happening.
Yeah,
So that
but
is kind of circumstantial evidence. You can't really prove they did that on purpose, but when it happens so frequently and you keep that incentive in mind, that it makes sense that they would want to do that from a PR
I
perspective,
think it makes sense that they would
it's a
want
problem.
to patch a bug before Pwned. I think that makes sense for incoming. Like, hey, we're going to get attacked here. Let's patch things right before so that they're attacking our most secure version. Like I don't deny that aspect of it, and I don't deny that there are probably some companies that maybe introduce a bug, maybe do something else with the bugs to kind of act in bad faith. But like, I don't think it's bad faith for any of these companies to be sitting on fixes and not patch them. Or well, I do think that would be a bad move on any company to do that. What is in bad faith though is the fact that they're patching right before the event. I think that is more. I think that's something more that ZDI should deal with, having a cutoff date, saying like we're
Yeah, I
using
agree.
stable at this point, so that sort of gaming shouldn't happen. But like, I would not say that a company should like not patch before it.
No, because obviously, like, if they find the issue close to the event, they shouldn't hold off on patching it just for the researchers' sake, right? They have the It's in their best interest to make sure their products are as secure as they can be for their customers. Um, that's just where I think like pwn to owns incentives are just a little bit weird in how they're aligned, and I think that is probably one of the better ways to handle it is to have a cutoff date where it's like, okay, even if you patch this issue, we are still going to allow researchers to submit it if you patched it after this date, right? That solves the problem, I think. Um,
Although I could
but it
understand why
does,
vendors would not like that because then they're paying out on bugs that they've already patched.
yeah, it's
I
it's a tricky
agree,
issue.
like Tone does have some weird motivations going on that front. I agree there. I feel like they've tried to approach that a little bit before. I think they did some like they were offering the Pwn bounties all year or something, so you could still report them. You wouldn't get like the master opponent points, but they at least like upped some of the bounties they were offering. I'm not sure if they've kept that up. I do remember a blog post back yet before we were even doing the podcast, where they kind of tackled that though.
Yeah. Um, but it kind of circles back to an issue we've talked about before, which is like um, not being like researchers not being paid out because of collision or whatever. It's just kind of a it kind of sucks for everybody. Like it's hard to pin blame on one side in particular. Um, that said, Synactive clearly thinks in their blog post that uh, they've been wronged by Western Digital, but they are going to be biased, right? Obviously, it is their 3 months of research that got thrown down the toilet when this patch went out. So it would be hard not to be mad and not to think that it was intentional. Um, but yeah, like this isn't the first time that researchers have been burned right before pwn to own. And like you said, it's not just Western Digital; it's a lot of vendors
I
that
mean,
are in Pwnome.
that part of
So
it honestly feels like, and I haven't participated in Pwnome, but it feels like that's part of the game. Finding the bug that isn't going to be patched, also, like finding the bug that'll survive long enough to go through Pwnome. Um, so if this were, a plant or something, like, this is a very simple issue. I mean, we've seen some simple issues in Pwnome, so I'm not too surprised, but I don't know. I mean, I can understand researchers not being happy, but that feels like part of the game.
I think that's a fair view to take. Obviously, if you're the researchers getting screwed, it's hard to think that way. But from the outside, I
Yeah,
think that
like,
is a fair view.
if it came out that Western Digital like introduced this bug in order to get researchers to spend time on it, and then patched immediately for, like, if there's some sort of bad faith intentional action like that, I would totally agree with. Well, I guess that's a tautology when I'm saying if there's a bad faith action, I'd agree it's bad faith. But in general, like, if there was something like that, then I would agree on bad faith. But without it, I don't know if I'd say this is bad faith. There's the potential for it. I just don't have enough evidence to say whether or not it is, or if it's just incompetence.
Yeah. All right. So I guess we'll move on to BrakTooth, which is named vulnerabilities and Bluetooth back in the podcast again. BrakTooth was published by researchers at the Singapore University of Technology and Design, where they disclosed 16 vulnerabilities that are common across commercial Bluetooth stacks, some various different chipsets. Unfortunately, only one of them. Unfortunately, in terms of like interesting covering it on the podcast, I guess fortunately for the vendors, only one of them leads to code execution. The other 15 of them are denial of service. Some of them are a little bit significant denial of service because they can be a real pain to recover from, requiring like a full device reset. But um, yeah. While they do have the vulnerability descriptions, which we will talk about a few of them, they do not have POCs released yet. They stated they're planning to release those in October, I believe, to give vendors who have their fixed release schedules that they can't really change easily. They want to give them time to patch them properly and get them shipped to devices, which is totally fair. They don't want to make it super easy for script kiddies to just take these and run with them and attack any of the affected devices before they could be patched. Um, they also have a lot of background information, which we'll kind of skip in covering because there is a lot of stuff there. They talk about the testing methodology, the affected chipsets, overviewing the attack scenario, which is basically an attacker using an ESP32 with a custom firmware and a PC to run the POC tool.
Yeah, I mean,
Um,
this feels like a really weird report to me. Just in the sense that, like, there is a good bit of background on it. Like, it almost reads like a white paper in that sense, where they're including a lot of background information, like everything you need to know is here. But then when they get
yeah,
to like the details of the exploits and stuff, feels like there's a lot of missing information about what's actually happening. Like, a lot of some of it is kind of just implied knowledge, where it's like, well, if you understood Bluetooth, you'd probably understand it. But some of it's just like, they're talking about the vulnerabilities, and it's like, here's what the vulnerability can do, and like some of the impact, but then they're missing really key piece of information. Maybe that's intentional, like I said, avoiding like script kiddies or something, but it just comes across as a fairly weird read to me compared to some of the
yeah.
other Bluetooth phones we've seen and covered.
So, talking about the vulnerabilities, we'll start off with the one that leads to code execution. This is the first one they list, 8.1 feature page execution. This one's in the Bluetooth Classic implementation in the Espressif ESP-IDF 4.4 and earlier. It's an out of bounds issue where a mutated LMP feature response ext packet can write 8 bytes of arbitrary data outside of the extended feature page table. And that's quite problematic because they note that the data that immediately precedes that table is a bunch of callback pointers. So attackers can, smash those callbacks to call whatever code they want inside of the firmware. They also note that that could have some additional implications for smart home type products because it can grant attackers control over the GPIO of the device. So as long as they can find and run functions controlling the actuators on the ESP32, there could be some interesting attacks you could do against like smart home technology. Um, that said, they don't go very much into detail about how uh, like that table is used or how the packet is being parsed. It is a little bit vague, like Z said. So they kind of they assume prior knowledge in the area, and you wouldn't be able to take this and write a POC with it very easily. You probably have to do a lot of research because they just leave out some key details there. But it seems like it is a pretty powerful attack against devices that are vulnerable to it. Because when you're talking about like Bluetooth Classic and that low of a level, being able to overwrite callbacks, generally, I don't think like 64-bit address space is really that common when you're talking about like chipsets like that. And ASLR might not even be that common. So being able to smash callback is a pretty big deal.
Yeah, in fairness, like actually utilizing this hack on a device, because this is kind of on a. Actually, I'm gonna just scratch that thought. Carry on.
Okay, all good. There was only other like one other bug here that I thought was kind of interesting, and that was primarily based on how annoying of a DOS it could be, which was the 8.6 vulnerability, the LMP2DH1 overflow. Um, Basically, certain layered SOCs can allow LMP packets over 2DH1 to have a length that overflows, and that overflow doesn't cause a memory corruption necessarily, but it does cause a deadlock in the packet handler. And like if it's a fault, then the device will automatically restart and try to like automatically recover from the issue. But if it's a deadlock, that doesn't happen. So it requires a full power cycle to restore Bluetooth connectivity. The dongle can't just automatically recover. So that is a little bit more of an annoying DOS. Most of the other DOSes, though, can be automatically recovered, and some of them are just like flooding packets and overloading handlers or exhausting resources. So they are valid attacks to point out. They're just not really interesting enough for to warrant covering, I don't think. Um, Z, if you had any other ones you think would be worth covering,
No, not really. I mean, it's really only the first one I cared much for.
yeah, that's kind of the similar boat that I was in. So yeah, I mean there is 16 issues there. If you are interested in those, you can check out the page, but we're not going to cover all of them on the podcast. Um, Another thing I'll mention is I did quickly glance into some of the other issues, and similar to what Z was saying earlier, some of them you need a pretty deep understanding of how Bluetooth works to be able to really appreciate it, because they use terminology in the vulnerability descriptions, and it's like, okay, it just kind of blows right past you if if you're not familiar with Bluetooth terminology. So
Yeah, which
um,
I feel is it's just weird because this is a named vulnerability. Named vulnerabilities are for vulnerabilities that are going to impact users, and they need an easy to talk about this set of vulnerabilities. So it feels like there should also be more clear information about the vulnerability. I don't know. I
yeah,
mean,
more
I
accessible descriptions.
I could probably rant on that for a bit about describing vuln, so I won't go there.
All right, fair enough. Um, but yeah, obviously the golden egg in there is the vulnerability that could lead to code execution, which doesn't affect. It didn't seem to affect as many devices as some of the other vulnerabilities did, but um, that's just the way it went. All right, so we'll get into our last topic, which is a research paper titled HyperFuzzer, and is about fuzzing hypervisors and virtual CPUs. One thing I'd lead with for those who are watching, you may notice the authors section on the paper is very interesting. For the most part, they're not from academia, but they're from Microsoft Research and Facebook, except for the two from Penn State University and KAIST. The reason I wanted to point that out up front is a lot of fuzzing papers we've covered in the past have come out of academia, and while they've had some neat approaches, practically it didn't really seem like they went that far, or they just kind of died after being released. There was just no further commits being made on the code. um, and with Microsoft being so prominent here, plus the fact that they claim they found 11 new bugs in Hyper-V, This could end up being a very important research piece and tool for Hyper-V security going forward. So I think this paper might be more relevant, perhaps, than some of the other papers we've covered. So
Yeah, I mean,
yeah,
some of the other papers we've covered ultimately end up being along the lines of let's, add some tracing and effectively, symbolic execution, doing hybrid fuzzing has been a lot of our papers, and some sort of taint analysis being tossed in there. This one, I mean, they're almost following that path on this one, I guess, a bit. It's at least a bit more, I think, a bit more interesting that we have covered in the past, though. I've tried to keep myself from covering every fuzzing paper I see because a lot of them do kind of follow that same sort of model.
yeah, there's quite a bit of overlap in fuzzing research. Um, So yeah, their paper, they start off with overviewing some of the challenges that come with fuzzing hypervisors, mainly being, the complexity of the interface, the sheer size of the attack surface, and the fact that you have to deal with multiple different architectures. Um, just issues with trying to test like all the possible states. That can be very difficult. So to tackle those problems, they went with a hybrid fuzzing solution, which combines symbolic execution to build inputs, as well as coverage guided fuzzing. And the observation that they based their work on HyperFuzzer off of was the fact that, um, to quote, a virtual CPU's execution is determined by the VM state, not by the hypervisor's internal state. So, to follow that mantra, they use a full VM state for fuzzing virtual CPUs. They also mutate instructions going into the virtual CPU, as well as mutating the architectural state itself, which I think might be one of the novel things being done here. The few hypervisor topics we've covered in the past, I don't think I remember seeing that really being done. Um, Finally, they only fuzz virtual CPU execution of the first VM trap triggered, which they note is important for keeping the dynamic symbolic execution manageable, right? Making sure that the state doesn't just explode. Um, the key novel thing that hypervisor or hyperfuzzer brings is what they call nimble symbolic execution, which uses Intel processor trace or Intel PT for recording execution traces to use. And that reliance on Intel PT is pretty important because one of their goals was high performance fuzzing. And they noticed that by using Intel PT in this manner, HyperFuzzer. I keep it's so easy to accidentally say hypervisor. HyperFuzzer runs 3 times faster than using hardware emulation with something like Box. So their setup consists of gray box fuzzing through AFL and a custom rolled white box fuzzing solution where they use SMT solving, and they integrate that into AFL's fuzz loop. On page 6, figure 6, they have a pretty good pseudocode snippet for how their setup works. They have the um, like a figure that shows the AFL fuzz loop and generally what they're doing at the top of the page. They then go into a lot of the implementation details, which I won't cover here. You will probably need a solid grasp on how hypervisors work to appreciate the nitty and gritty implementation details, because there were some parts where I kind of had to jump around where I don't do hypervisor stuff. Um, they base their evaluation on a few key factors. The ones I found interesting were performance, precision, which is based on how many input dependent branches they could cover, um, coverage with their hybrid approach versus just gray box or just white box, as well as the most important metric being does it find bugs. The performance we kind of already covered. They found that it performed well, running roughly 3 times faster than hardware emulation. Bugs found was also kind of already covered. They found 11 previously unknown bugs in Hyper-V, 6 of which were marked as security critical because they could be used for VM escapes. They also noted that most of these bugs were found within hours of setting up the fuzzer. Coverage, they found Hypervisor got much higher coverage compared to pure gray box or pure white box approach. They have some graphs on page 10, figure 9. They're really small, but if you zoom into them, you'll see that they beat out white box and gray box pretty significantly on hypercalls, API-C emulation, and MSR emulation. It's just the task switch graph that they didn't top. And they were, I think gray box fuzzing maybe did a little bit better on coverage there. But for the most part, The hybrid fuzzing setup got higher coverage faster, so they achieved that goal as well. Um, Finally, they list the limitations of their setup. The most obvious one being that because they're using Intel PT, you have to use Intel VMX and Intel hardware to leverage this. So any virtualization, um, like AMD based virtualization, like AMDV, obviously you can't really fuzz that with this setup because AMD doesn't have a processor trace equivalent, as far as I know, which really sucks. I really wish AMD would get one. I don't know why
Yeah,
there's no
still
interest to
none
do
as
that,
far as I'm
but
aware.
yeah, because processor trace is a very cool technology. It's leveraged a lot in fuzzing for code coverage, but and symbolic execution, whatever. It's just, man, I really wish AMD had it because their AMD's hardware is really good. Um, anyway, the other thing is it doesn't support multiple virtual CPUs for white box fuzzing, which can make it more difficult to find race condition type issues. They note that in order to support fuzzing multiple virtual CPUs, they would need a new technique for doing the tracing because PT is kind of limited. It can only do one at a time, I think. Um, and yeah, so they would need a new technique for doing the tracing and symbolic execution. So they just noted that that's being left for further work. Um, Overall, I think this was an insightful paper. I found it a cool read just because I find hypervisor and virtualization type stuff to be magic. So it's nice to see some of the lower level details about how it can be targeted and fuzzed.
Yeah,
That
we
said,
haven't.
hybrid fuzzing is not really that new. So there's some cool aspects to it, but it's kind of taking an existing approach and applying it in a new way. Go ahead, Z.
Yeah, well, I was just going to say, like, haven't seen a ton of hypervisor fuzzers in what we've covered. I think we did cover one. I want to say like hypercall or something. Oh, I remember us covering one hypervisor fuzzing paper. So it's interesting to see fuzzing. Some of the advances being made in the userland fuzzing are moving forward, are starting to hit, hypervisor fuzzing. So it's just interesting to see that.
Yeah. Like I said, hybrid fuzzing is nothing really new. But what's new is how they're applying it for fuzzing hypervisors. But yeah, that basically sums up all of the topics we have for this week. Thank you to everyone who tuned in. You can catch the VODs on Twitch or on YouTube at 8 p.m. Eastern on Wednesday. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. Feel free to join our Discord and follow us on Twitter. You can find links at the bottom of the page or in the description of the video or in chat. Uh, Z sometimes puts them in chat. Um, we'll be back next Monday for our bounty episode at 3 p.m. Eastern, 12 p.m. Pacific, and Tuesday for the binary episode at the same time we did it today, 7 p.m. Eastern, 4 p.m. Pacific. With that said, we will see you all again next week.